Today we'll give a geometric interpretation of the solution to a linear system where we have three unknowns. So our solution here will be for the unknown variables x1, x2 and x3, which is an ordered triple. So note that these systems of equations written with three variables are the equations of a plane. So we have a constant by x plus a constant by y plus a constant by z is equal to d, which is another constant. So similar to two-dimensional linear systems, we have three groups of solutions. So the first is no solution, where we have the planes being parallel to each other, so the planes don't intersect at all. And you can also have two planes being coincident and one plane being parallel to those planes. So you'll also get no solution in this case. And even if you had one of these coincident planes intersecting both planes, so maybe you had something like this, still in this case you won't have a solution, because all the planes must intersect somewhere. And think about other scenarios where you'd have no solution. Now a case where you'll have one solution is where the three planes intersect at one point, as we can see. And you can also have infinitely many solutions. So these are examples of three planes intersecting at a common line. And remember that a plane is infinite, so this line would extend indefinitely. And here you have three coincident planes, so you'll get infinitely many solutions. And this extends generally to all linear systems, which either have no solution, one solution, or infinitely many solutions.